Hello, this is M. Thomas Apple, the author of the new science fiction book Bringer of Light, coming out March 15th, really soon. This is a video that I made to explain the locations, and there are lots of locations. Or, sure, there's lots of planets and moons around. So let's take a look. So, as I've said in my other video about the characters of the book, this is a futuristic science fiction novel that takes place all the way from Earth, mostly the moon, all the way out to Neptune. But how far away are these places? There are a lot of locations in the book using a lot of the solar system. So let's take a quick look. Our story first begins out near Neptune. Neptune is the 8th planet in the solar system. By current astronomical standards, it is the last planet in the solar system. That's a debate that was held about 20 years ago. We'll talk a bit more about that when I show you the whole map of the solar system. The story quickly goes back, though, to the moon. Bouncing back and forth, as I said in the introduction video, a leapfrogging narrative. Then it goes way out to Jupiter. Jupiter is the largest planet in the solar system. Probably all of you know that. You may not know that there are lots of asteroids both in front of Jupiter and behind Jupiter, permanently, more or less, in orbit in front of the planet and behind the planet. This is because of the Lagrange points. This is where the gravitational force of the sun and the planet are basically at an equilibrium. There sometimes can be new asteroids that appear. There might be lots that have since left that area due to various events in the past of the solar system, but by and large, I think about 2/3 of the asteroids are in front of Jupiter. We call them Greeks, and that most of them have Greek names, except for Hector, because he was named before the system was really in place. And there's about 1/3 of the asteroids in Jupiter's orbit are behind it in Lagrange point 5, and these are called the Trojans, although collectively they're all called the Trojans. In my story, these two areas are called the happy hunting grounds, because asteroid hunters know more or less where these asteroids are permanently. They don't have to go searching too hard for them. Although we all see movies with asteroid belts and they're all really close together and ships can go hiding between them and stuff. The reality is they're very spread out. So it doesn't really look like the image that you see in front of you. But there are lots and lots of asteroids. They're left over from the formation of the solar system some 15 billion years ago. Of course, most of my story takes place on Mars. I haven't bothered to name the places, to be honest. You probably are familiar with lots and lots of science fiction movies and novels based on Mars, and they use all of the names. You can go finding the names on your own. I didn't want to get bogged down in the locations of people. You can kind of use your imagination more or less. Remember, this is a science fiction novel, not a science novel. There are, of course, some events that take place out near Saturn. Saturn is the most recognizable of the planets because of its big rings, although Jupiter does have rings. Uranus does have rings, so rings are not unique to Saturn, but Saturn is unique because of the shape of the rings and also because of the number of moons that it have. There's one right behind me, actually, which is called Enceladus. And every time I tried to use PowerPoint to do automatic subtitles, it wrote it as Enchiladas, which taste good but aren't exactly an icy moon of Saturn. The most commonly used moon in my story is Ceres. That also, PowerPoint had a problem and kept writing cereal for that. Actually, it is related to the word cereal. Ceres is the name of the Greek goddess of the harvest, from whom we get the word cereal, as in breakfast cereal, meaning grain. So this is where the Ceres Mining Consortium is in the story. They are in charge of processing the asteroids sent to them by the asteroid hunters. And of course, there's another location whose name will remain a secret. Many of you who are familiar with the solar system may be able to guess. It's not commonly taught in schools. And don't forget, these images are not to scale. Obviously, Jupiter is not the size of Mars. Mars is about 2/3 the size of Earth, meaning the gravity is about 2/3. And yes, that has a lot to do with what happens in the story. So, the three main locations in the story are Mars, Ceres, and the Moon. Eventually, all of the threads from the leapfrogging narrative gather together, and they end up on Mars, except for one group, again, who goes to a mysterious location to round out the story. And these are the three main groups of people. Maybe I should move myself. Okay, so the three main groups: United Mars Colony, Ceres Mining Consortium, and the Lunar Base. These are the three main locations. Okay, but how far apart are these places, really? I've got a brief model of the solar system to my right, and I'll show you another version in just a minute that spreads it out horizontally. I have to apologize. The information from this slide in the previous video about characters, technically the description about the Kuiper Belt was not accurate, so I've changed that to reflect the real science. We know that the Kuiper Belt begins just past where Neptune is. Neptune is really, really far away. It's on average 2.8 billion miles away from the sun. And that's about 4.5 billion kilometers. And we use the term AU, 30 AU. AU means astronomical unit. 1 AU is the distance of the Earth to the sun, which on average is 93 million miles, or about 148 million kilometers. Now, I say on average because a lot of models like this one, they show the orbits as being perfect circles. They're not. They're not perfect circles at all. They're more like an oval shape. And actually, each planet is not just orbiting the sun is also orbiting them, which makes it very complicated. The Earth technically doesn't orbit the sun. The sun and the Earth orbit a mutual point between them, where their gravitational forces match and are equal. Of course, the sun is much, much stronger, which is why the Earth is much closer. Neptune is much, much farther away. It takes about 4 hours for sunlight to reach Neptune. That's how far away it is. So if you want to do the math, 93 million times 30, carry the 1, just say 30 AU. It's simpler that way. The Kuiper Belt begins just past Neptune. About 4.6 billion miles from the sun is where it ends. So it starts at about 30 AU and ends at about 50 AU away. There are a lot of icy bodies in the Kuiper Belt, named after Dr. Kuiper, of course, despite the spelling. Dwayne Kuiper of the former San Francisco Giants probably can agree that's how it's pronounced. When I was a kid, Pluto was considered the 9th planet. It has since been demoted to dwarf planet status, just like Ceres, which you see up in the asteroid belt between Mars and Jupiter, and Eris and another one. The Eris is not in my story so much. Oops, that was telling. But Pluto is definitely not in the story. It is not one of the 9 planets. As I said, technically it's a KBO. It is in and out of the Kuiper Belt. So it is basically the largest CBO, the largest Kuiper Belt object, or trans-Neptunian object. I use the term TNO in my book. The past there is a lot of empty space, basically. We enter interstellar space once you get out of the Kuiper Belt. And how do we know this? How do we know where it ends? Well, the 2 Voyager probes, not that Voyager, the 2 Voyager probes that were launched from NASA in the late 70s have both made it into interstellar space. Voyager 1 was reported a short time ago as having problems with its messaging. It's just sending out a series of random nonsense now, so probably the battery's about ready to die. Voyager 2 is currently still heading out towards the Oort cloud. It will not enter the Oort cloud for the next 200 to 300 years. We don't even really know if the Oort cloud exists. Right now, it is still a hypothesis. So how long do we have to wait to see if there really is an Oort cloud? I don't know. I'm not going to be around in 300 years, probably. Now, another way of looking at the Oort cloud is this way. And again, with a lot of these things that you see online, they are not to scale. I'll show you the solar system up to Neptune done to scale by people in the west coast of the U.S. on a desert, actually. This is typical. They show you where 100 is. 100 is the end of the heliopause. That's basically the rays coming from the sun. To get to that point, you have to go through what's called a termination shock. And then you enter interstellar space. So technically, after you get past the heliopause, you're in interstellar space, even though you're not in the Oort cloud. The Oort cloud is hypothesized to begin at 1,000 AU away. In between 100 AU and 1,000 is an area called the scattered disk, with a few objects, but very, very little stuff there in general. Keep in mind that the Kuiper Belt, even though on the previous slide looked like it had a lot of objects in it, that's only about 10% of the mass of the Earth, let alone the other planets in the solar system. So these objects are really spread out. The Oort cloud, we think, ends about 100,000, maybe 100,000 AU away. That's really, really far. So it would possibly take the Voyager probe up to 30,000 years to get through the Oort cloud. At which point, Voyager 2 right now is heading out at a 36-degree angle, and it's aiming itself towards, right now, what is the constellation of Sagittarius. By the time Voyager gets out that far, things will have moved. We will have moved. Our solar system is currently moving. So is every other solar system. So by the time it reaches there, computer modeling now says it will basically wind up in the constellation of Andromeda at a star called Ross 248, which is actually moving closer and faster towards Voyager than Voyager is moving towards it. At some point, the Voyager battery will also die, and we'll have two dead, not even robotic probes continuing their motion out, and who knows, maybe somebody will find them. Hopefully, humanity is still here when that happens. Now, as I said, the solar system that we just saw was not to scale. This is one of the few models that I found online. There are a couple others. You can get some videos from various places around the world. I think there was one in Sweden. There was one in Boston that was taken away for some strange reason. I was living there at the time. What people do is they choose an object to represent the planet, and they try to make it proportionally to scale to see how far away things would be. So these are the people who actually made videos called To Scale. You can find them on YouTube. They took the sun, which they represented as a disk about this big, and the Earth they represented with a marble about that big. And you can see how close the Earth is. It's right there. And then there's Mars. And then there's Jupiter. And then there's Saturn. And then Neptune is 5.5 kilometers away from the sun in the middle. This is a representation of how truly far away these objects are. So obviously, there's a lot of space. There's even a lot of space between the Earth and Mars, because most models show the planets as lining up. That never happens. No, it has never happened. All 8 planets have never been lined up, and they probably never will. The conjunctions are very, very rare. If you're lucky, you get 3, sometimes 4. So that means that the Earth could be over here, Mars could be way over here. Right now, Mars is currently 211 million kilometers away from the sun. And on average, it's 228 million kilometers, about 1.5 AU. So again, just past the Earth. But the two planets could be 250 million miles apart. That's really, really far. It probably won't happen. On average, they're about 140 million miles apart, or about 225 million kilometers on average. That is a very long distance to travel. Every 26 months, the Earth is in opposition to Mars, which basically means the Earth is in between the sun and Mars. That's when the rockets send off every 26 months, because remember, both planets are moving around a central point at different speeds. So even at the closest approach, it still takes a minimum of 9 months with our current technology to get something to Mars. There actually is a lab based in Japan, I think. They're experimenting with something called a photon propulsion system, and they think that they can get an object about 100 kilograms or so in size, a robot of some sort, and they can make this thing go close to the speed of light and get from the Earth to Mars in 3 days. You cannot do that with a human body. We will explode because of the pressures involved. There's no way that a human body could stand a G-force like that. But maybe, who knows what will happen in the future. After all, I'm writing science fiction and not science. That said, my book is about to come out. There is some science in the science fiction. That's why it's called science fiction and not fantasy. And I'll be making a video to talk a little bit about the science. If you're interested, please come back and check it out in a few days. And you'll learn more about quantum technology. Yay. Thank you for watching. Hope you enjoyed the video.